Hi everyone, my name is David and I'm part of the engineering team here at Define Instruments, and today I'll be taking you through a short presentation to familiarize you with one of our latest products, the Sentry Trip Amplifier. So we're just about to get underway here, and just hoping everyone can hear me. So if you can hear me, perhaps you'd like to leave a comment in the chat box on the right hand side of your screen, and you can let us know perhaps where you're listening from. You can use this chat box at any point during the presentation to ask us questions. The presentation is going to take about half an hour. We will also be adding this presentation to our webinar archive that you can find on our website. So if you find the content useful, then feel free to come back and check it out later on. We also have other content up there, and we will be adding to that archive as we go. So stay tuned and keep an eye on that one. Okay, let's get started. This is the Sentry. It's a small trip amplifier that is designed to be used for monitoring input signals from common sensors found in an industrial environment. The input takes many kinds of small, weak signals and converts them into standard signals like 4 to 20 milliamp that can be safely sent to other equipment a long distance away. It also is able to react to the input signals it receives and switch on and off its two relays in order to provide control and alarm functions. It's designed for what you might like to think of as set and forget applications, where the unit is installed in a cabinet and it does its job with minimal intervention. It has a 4-digit LED display for easy diagnostic use with configurable decimal point options, and it has programmable input scaling. The programmable input scaling is quite neat because it allows you to easily configure the display to show a scaled version of the input signal that is more meaningful to the user than a raw voltage. As an example, it might be configured to show a temperature or maybe a flow rate in liters per minute. We're going to have a look at some of its more interesting features today, like the universal input, the universal power supply, the relay outputs, and the optional 0 or 4 to 20 milliamp loop, or the 0 to 10 volt analog outputs. The universal input is the ace up the Sentry's sleeve. We call it universal because, unlike many similar products, you don't have to limit yourself to only one input range when you buy a Sentry. It makes ordering and installation much easier because the input will work with any of the available input signal types. Each range that the Sentry offers comes pre-calibrated from the factory, enabling you to configure the unit without having a sensor present. The inputs are all electrically isolated from the output as well, and they're isolated from the power supply so that you don't have to worry about signal degradation due to earth loops and other hard to track down wiring issues. The Sentry accepts temperature signals from all common thermocouple types, as well as 3-wire RTD and NTC temperature sensors. The Sentry also monitors a 0 to 20 or 4 to 20 milliamp current loop signal, or a 0 to 10 volt input signal from the process output of other equipment. Its voltage input can be configured in many different ranges. It starts as small as plus and minus 200 millivolts, and it goes all the way up to 300 volts DC. It also has a digital pulse input that can be used with pulse signals from devices such as flow sensors, and has a working range from 0 to 2 kilohertz. The Sentry also has a potentiometer range for use with ratiometric sensors, and for measuring high current signals, it can be paired with one of our optional external AC current sensors. The power supply on the Sentry supports a wide operating range, allowing you to operate the same unit from either 20 volts DC or the AC mains supply with no reconfiguration of the unit. Being able to use the wide range power supply in one model means that you aren't going to have to worry about blowing up the unit by putting the AC mains into a low voltage only model. This makes it much simpler to install in unknown systems, as you can connect the unit to almost any available power source without having to worry about picking the right unit beforehand. The Sentry also can provide 22-volt excitation to sensors. This is fully isolated from the AC/DC main input supply, and it's ideal to use if you're using a loop-powered sensor with the Sentry. The Sentry is available with an optional current loop retransmission output. It can be configured in either a 4 to 20 or a 0 to 20 milliamp mode. This is an active loop output. If you don't know what that means, it means that the power for the 4 to 20 milliamp loop comes from the Sentry, so you don't need a separate power supply to power the loop. The Sentry also has a 0 to 10 volt output that can be enabled instead of the current loop output. It comes with both in the same unit, so it's just an option that you pick and set up as to which one you want to use. It doesn't do both at the same time though, so you do have to pick one. The signal value for all output retransmission types is always derived from the value shown on display, and it can be rescaled to nearly anything you like. It's a very flexible system, and it doesn't force you to work out what your input value would be for specific output values like 4 milliamp and 20 milliamp. Instead, it lets you pick arbitrary points to calibrate to. This saves you from poking away at a calculator if you're working with unusual numbers. As an example, if you're using the Sentry with a temperature input, you can set it so that when the display shows 10 degrees, the output is 5.3 milliamp, and when the display shows 105 degrees, the output is 19.2 milliamps. Pick any four values you like, and the configuration software will work out the scale factors to make it happen. The Sentry also allows you to pick failure behavior for the analog output. For example, it can output 21.1 milliamps if a sensor fault is detected. The Sentry also has two relay outputs. The first relay output provides both normally closed and normally open contacts, and the second provides just the normally open contact. Normally open contacts are great for control applications where the safest state to have is the off state, like a heater element where you wouldn't want the output to stay on in case of a controller failure. Normally closed contacts are great for alarm applications where you might want the opposite and be able to turn on a siren if the controller fails or loses power. The relays have multiple operating modes and can be configured independently from each other, and we also have special linked modes such as pump alternation control modes where the two relays work in tandem. We will have a closer look at this mode later on in the presentation. We commonly come across trip alarm applications where the device is used in a set and forget scenario. In most of these situations, it's desirable to have a way to prevent well-meaning yet uninformed people from accidentally reconfiguring the unit into the wrong mode. For peace of mind, the Sentry is an excellent choice because there are no buttons to press, and the only way to change its settings is to connect it to the computer and use our easy-to-use configuration software. The Sentry does have a user input switch connector that can be used to reset relays when they are set up in a latching mode. It's also useful in situations where you want manual reset of the alarm. The manual reset disables the alarm until the unit has returned to its no-fault state. This is great for doing something like silencing a buzzer that's on continuously until a slow condition is restored. The user input switch is provided on a two-terminal connector, so you can wire your own push button onto a panel or anywhere it's convenient for the user. The switch can also be used as a manual 0. When you enable this mode and press the button, for the current input signal will be used as a reference point. The display changes temporarily, and now all measurements are taken relative to the 0 point. A common example of this behavior would be analogous to the tare button on your kitchen scales. So you put the bowl on top of the kitchen scales and then you push the tare button and it zeroes out for the weight of the bowl. So it's the same behavior, but it works on all the modes, whether it's voltage and things like that. It's great for with level sensors and things in a tank where you might want to go from the bottom of the tank, or you might have a bit of residue in there. The Sentry is very quick and easy to set up. You don't even need a power supply to configure it, just the USB bridge key, and it will power itself from your computer. Do keep in mind that when you are using only the USB bridge key to power the Sentry, the majority of the functions will operate as they normally would, but the analog output won't operate and the excitation voltage won't be available for powering sensors. However, you can still configure the current loop and the 0 to 10 volt output. as the Toolbox software has a handy live display to show you what the pre-calibrated analog output voltage or current would be if you did have the power connected. One of the really nice things about the Toolbox is that you don't have to leaf through a long and complicated manual to set up the unit, as we have designed the software to be extremely easy to use. You'll be very pleased to hear that we don't expect you to have to decipher cryptic menus or memorize impossible button combinations. Most things are very intuitive in the software, and if you do find things confusing, the built-in help pane will always update depending on what you click on, and it will show you the relevant information you need to know right there on the screen when you need it. Let's have a look at some application examples, and I will take you through the software and I'll show you how easy it is to use. So the first application example that we're going to have a quick look at is a industrial water bath. So this might be in a chemical process where we want to put some vials in water and have them at a monitored temperature. So an alarm is turned on in this scenario when the temperature exceeds when the temperature drops below a minimum value, and there's also a safety cutout so that the operator doesn't get burnt by the water temperature going too high. So we're using an RTD sensor to measure bath temperature, and we have relay 1 set up to turn on a siren if the temperature drops below 40 degrees. So we're saying that that's a critical point for our process. And relay 2 will turn on when the temperature exceeds the critical limit. We've said 75 degrees so that the operator doesn't get injured. That output is going to be used to cut power to the heater. We're assuming that in this scenario the bath has its own controller, but this is just a second failsafe. We're also going to use the 4 to 20 milliamp output from the Sentry to send data to the control room PLC system, so that that data can be used for data logging or maybe for batch quality control on the batch in the bath. We're also going to be using the reset button as a manual relay reset for relay 1 so that we can silence the below 40 degree alarm. Another application example that we're going to have a look at is water tank level monitoring and control. So this is a control application as opposed to an alarm application. In this scenario, we have an industrial process that is being cooled with a water supply from a local river, and the water is being pumped from a local water source into a tank where the level of the tank has to be controlled, and then it's sent on to the rest of the factory for cooling. So we're going to use 0 to 10 volt signal from the level sensor as the level input, and we're going to use the 2 relay outputs on the Sentry to control pump motors. So it's worth noting that the tanks, both of those tanks we've shown there aren't a linear shape. So what that means is, for example, the green tank on its side, when you're a third of the way up, you don't actually have a third of the volume. When you're half, you do have half, but it doesn't track properly because of the circle shape. So that's something that the Sentry is able to cope with. So we'll have a look at that now. Again, we're also going to use the 4 to 20 milliamp retransmission output to send that level to other devices. Okay, let's have a look at the Toolbox software and we'll get a feel for how to run it. So this is the Toolbox software here. This is a cutting-edge version. It's not quite released yet. It's got a few new features. One of the really neat things that I'll show you later on is this simulator mode, which lets you run it without having a meter attached. So let's click the green button and we will be able to connect to the device. I have it plugged in via a USB programmer, as you can see down here in the right hand corner. Those are available from us as a programming kit. You can use the one programming kit to program all your devices. So let's click connect. So it automatically finds the Sentry. And this is our starting point for configuring the unit. So one of the first things you might notice is we have a display up here in the top right hand corner. This gray box has got the current value shown from my unit. So I've got it attached to a little RTD simulator here. So if I turn the knob, the number changes. So that gives you an up-to-date view of what the current input signal is. We also have down the bottom here, we have in the bottom left-hand corner a live trace graph, which is currently showing us the input signal. So if I turn this knob drastically, the value jumps up and down, and we can see the signal going all over the place as I change it. That also follows the output as well. So I can see here in red, as I change it again, the output is changing to show me the current output value. On the right-hand side here, you'll see that the page is split in half, and we have what we like to refer to as our interactive help, and there's a wiring diagram up there which shows you how to wire up the unit. There's lots of explanations for how things work, so keep an eye on that as we go through this demonstration, because you'll notice that things change as I click on them. So for example, if I click on the temperature scale here, temperature scale has now jumped up in the help, and it's giving me all of the help I need as I need it. So it'll continue to move around. So this temperature mode would be great for our first application. So to select RTD, we start with picking temperature, and then we can pick which type of temperature probe. Do we want RTD or thermocouple or NTC? So it's all very straightforward and intuitive. But I want to dwell in a bit more detail on the second application. So let's have a look at our level sensor and pump application. So for that application, we want to put the unit in 0 to 10 volts. So to do that, I click on input mode. There's a voltage DC option here, and then the second option down is input range, and for that I will select 0 to 10 volts DC. So you'll notice that the input wiring diagram has now changed, and that's showing us 0 to 10 volt wiring there. So I'm going to go ahead and I'm going to click apply, and I'll just change over my input here to my 0 to 10 volts. Okay, and you'll see I've got 0.8 volts going in at the moment. So that's just coming off a power supply on my desk. So I can change that value, and the value changes. So let's have a look at how easy it is to configure the set points. So for the set points, we click on the green set points tab, and we have the option of configuring the 2 set points. So let's go for a really basic scenario where we just want set point 1 to turn on and off for a single pump. And so to do that, we go mode, control, we find the pump control modes in here, and let's go for the function. In this case, we want on, off, energized below. So we're going to set a threshold value, and when the value drops below a value, it's going to turn on the pump. So let's say we want the pump to turn on when the value drops below 4 volts, and we want it to turn off again when it comes back over 6 volts. So we can click apply. And when I adjust the voltage down, watch the top right hand corner. The value on the screen there is now 3.7 volts, and you'll see that set point 1 is on. If I wind it back up, set point 1 stays on, and eventually we go over our 6 volts point, and set point 1 turns off again. So that's pretty easy. Let's have a look at maybe expanding that a little. So we can put set point. Let's have a look at a second mode where we're going to have 2 pumps controlling the water level in the tank. So in this scenario, we've got a backup pump and a main pump, so that if one pump dies, the other pump can take over, or if there's a high demand and one of them can't keep up on its own, the 2 will turn on. So for this, we're going to look at a linked mode. So control mode, and then a function here is pump alternation with backup in a fill mode. So what this mode means is that each pump is going to take a turn at turning on to fill up the tank, and this performs load sharing on the two pumps. And also, if the first pump fails, the second pump will turn on. So you can see on the right hand side here a graph illustrating how that works. So we've kept 4 volts and 6 volts for the first pump, and we're going to set the backup to turn on at 3 volts and turn off at 4 volts. So if we have a look now and we wind the voltage down again, when we get to 4 volts, one pump will turn on. Okay, so pump 1 has turned on. When I go back over 6 volts, pump 1 turns off. And now the next pump that turns on will be pump 2. Oh, sorry, I haven't applied it. That does help. So now pump 2 has turned on. So that's quite a good mode for load sharing. Pump 1 is turned on. But if I continue to go under and I go under 3 volts, now both pumps have turned on as a backup scenario. This is all pretty easy to do, but at the moment we're still looking at everything in volts, which is perhaps not the easiest way to be dealing with things. Ideally, what we'd like to be able to do is to have the screen show us in liters. So let's have a look at our input tab, and we can change the scaling. So let's go for custom scaling. When we click the edit button here, we can say an input value of, let's say 2 volts is going to be 50 liters, and 8 volts is going to be 100 liters. And I can adjust the number of decimal places. I'm going to put that down to, excuse me, 1 decimal place, and I will apply. Okay, so now with 5 volts in there, we are showing 75 liters. So we can quite quickly scale things, and we can have things in engineering units. Let's say we're going to use a tank that's round and it's lying on its side, so it's a non-linear tank. We also have the linearization option here under the input tab, which I can turn on, and we can then load in a lin table with different points. So the input points and the output points allow you to scale it to exactly the shape of your tank and to fit the curve to your tank's profile. There's 32 points there available for use. You don't have to use all 32. You can use as many as you like. Okay, so that's the control modes briefly outlined. We do also have alarm modes in here, which are easily highlighted into different common applications. So we have alarm above a trip point, alarm below a trip point. We also have above with hysteresis. The hysteresis is quite easy to set with this unit. You just type in a value here. So our trip value is 400, and the hysteresis, let's say we want 10. Actually, I'm going to make that a bit lower. I'm going to make this 75 so we can play with it. And then we can click apply. So now, like shown in this graph, it will turn on when it goes over 75, and it will turn off when it drops under that value with the hysteresis. So alarm 1 is on. If I wind it down, it should turn off again at 65. And it does. So that's how we set hysteresis. And again, you'll notice it doesn't turn on until we get over 75. So that's quite simple. The other neat thing about the toolbox, we have a import and an export option here. So I'll show you how that works by demoing the simulator mode. So if I disconnect and I go to the simulator tab here, I can pick a meter, any meter from our range, and I can simulate here. So I'll simulate the Sentry, and you notice we get a very similar view. So you can actually, once the software is released, we can You can demo this with a customer without having the unit available. You can see all of the ranges that we offer, and you can get all the help. And if you're trying to set up a unit for yourself, you can set it all up here, and you can actually export the configuration, and then later on when you connect to your meter, you can import it again and apply it. Also, if you want to set up a whole lot of meters, the import and the export option is great for doing that, because you can keep them for later on. Or if you want to remotely give someone technical assistance, then you can create a configuration file for them and send it to them, and they can apply it remotely. All right, so that's covered the majority of the Toolbox features. Right, does this all sound familiar? Those of you who are familiar with our products might have noticed a lot of the capabilities of the Sentry overlap those found in our popular Merlin panel mount indicator. When we developed the Sentry, we started from the Merlin, so a lot of the design is actually very closely related. The Sentry has the same input circuitry found in the Merlin, and we've kept the same power supply. This means that any sensor you can get working with the Merlin will be just as easy to get working with the Sentry. Both units work with the Toolbox. In fact, a lot of our devices do. The simplicity factor is really important to us. Both devices also have the user switch input, which functions the same way in each case. There are some small differences between the two, so I'll just quickly go through them now. But before I do, we will be answering questions in just a moment, so you might like to start typing in your questions now if you have any. The first thing most people will notice that is different between these two is the shape and the mounting options. Because of these differences, they would normally be used in slightly different applications. There are two key differences in features. The first is the analog output types. The Merlin only has a 4 to 20 milliamp output, as opposed to the 0 to 20 milliamp output and the 0 to 10 volt output on the Sentry. The second major technical difference is the relay configuration. The Merlin doesn't have a normally closed relay output. Whereas the Sentry does have one normally closed, normally open relay, and one normally open. Again, as with the inputs, the Sentry analog outputs and relays will be able to fit right into any application that you have already found to work with the Merlin. We aim to be applying for UL approval for the Sentry very shortly. If you require it already, then the Merlin might be an option for you as well. But if UL is key to your application and you think the Sentry is a good fit, let us know, and we will make sure that you are the first to know as soon as it becomes available. The Sentry is also not designed to the same IP65 standards as the Merlin, so an external housing around the DIN rail will be required to provide environmental protection. But generally that would be commonplace for most applications anyway. All right, we're going to take some questions now if we have any. Perhaps there's an application that someone would like me to demo in particular with the Toolbox, or something that you would like me to clarify. Just a reminder that a link for this presentation content will be up on our website. And if you have more questions on the Merlin that I very briefly touched on as well, we will be covering this in a presentation, in our next presentation. And we'll also email you through a link to this presentation very shortly after the webinar has finished. And if you have a particular application in mind, feel free to email that through to us as well. So I see a question there from Kathy regarding what applications, I think you're asking what applications we see this used in. And Anthony has commented often temperature alarms. And as I said earlier, generally it's in a set and forget scenario where it would be locked away in a panel somewhere, and it's just sort of doing its job, and it doesn't require a whole lot of user input. Okay, well, I don't think there are any further questions. We will keep the chat room open for a little while after we end this presentation, so we can reply to them in that format as well. Thank you very much for attending. It was a privilege to have you with us, and we hope that you found this presentation informative and helpful, and we hope that the Sentry will be an excellent fit for your applications, and that you'll enjoy the simplicity that we have worked hard to build into it. Thank you very much, and I hope you enjoy the rest of your day.